Hi guys, welcome to section 1.3. What we're going to do with this section is split it up into two different recordings. So this is the first one. So for most of the notes you will have this year, I want you guys to always do your warm-up problems before we start. I'll pause in a second so you guys do have the time. And if you want to pause now, do that. But a warm-up is something that things you should know before this lesson. So if you don't know any of the warm-up problems or you need some help, always go back to the previous lessons because that's what I expect you to know before we enter into these new set of notes. So pause here and continue doing those and then press play when you are ready for your answers for your warm-up. All right, so should be done with your warm-up. We did rationalizing earlier, so make sure you guys multiply both top and bottom by square root of 5 to rationalize your denominator because you cannot have a radical in the bottom. Then number 2 is dealing with exponents, more in course readiness for this. So make sure you guys get those little aspects down. And number 3 is all about square roots and simplifying and multiplying those. All right, so what we're going to be doing today is solving equations with fractions. So your favorite things in the world I know are fractions, so we're dealing with them today. So what I want you guys to do with these types of problems, you guys know how to solve equations, but the fractions are what throws you guys off. So what you want to do, and you're going to hear me say this a lot, you want to clear fractions. Anytime you see an equal sign with fractions, you clear them, okay? So there's several topics in ALEKS like this. This will happen the entire school year. So make sure you guys are remembering to clear fractions. It's like your huge word. I'm going to say it a ton. So how you clear fractions, what you're going to do is multiply all your terms. So for example, the first one has 3 terms. Multiply each of those terms by the LCD, or the lowest common denominator, to clear it. So look at the denominators that we have here. We have 2, 4, and 5 as our denominators. The lowest common denominator of 2, 4, and 5 would be 20. Okay, so what I like to do is write 20 over 1 in front of, well, I don't want to confuse you there because of the minus sign. So I'll put 20 over 1 here on the right of it, and then 20 over 1 over here. So just put it like either in the front or next to each of the terms, wherever it fits. Or if you want to rewrite the whole problem, go for it. Now, the reason you do this is so you can start cross-simplifying. So for the first term, I'm going to go like this. 2 goes into 20 10 times, and then we do 10 times 3. So you multiply the numerators across, and you get 30v. Now you do the next one. 4 goes into 20 5 times. Now you multiply the two numbers on top. -3 and 5, -15. 5 goes into 20 4 times. -3 times 4 is -12. This is how all of your problems should go. When I say clear fractions, I mean the very next step should have no fractions. If you have fractions and you didn't clear them. So make sure you guys are getting to this step before you move on. Now from here, just an Algebra 1 problem. We're going to go through this very quickly. Add 15 to both sides. Divide by 30, and then always reduce your fractions. The silliest question I get every single year, a million times, is, do I need to reduce my fraction? That's a very silly question. Of course you need to always reduce your fraction. If you do not, then you don't get full credit on your assessments. So your final answer is 1 over 10. All right, number 2, again, look at the denominators and you multiply each number or each term by that LCD. So we have 3, 2, and 5. The lowest common denominator of 3, 2, and 5 is 30. So you write 30 over 1 next to each of these terms. And again, if you want to just completely rewrite this out so it looks a little better, go for it. And then we start cross-simplifying. So 3 goes into 30 10 times. You multiply it 10 times -4, negative 40w. 2 goes into 30 15 times. Negative 5 times 15 is negative 75. And then 5 goes into 30 6 times. And so you get negative 54. Again, at this point, you should have no fractions. You should have an Algebra 1 type problem, and you're ready to go. So the only really new thing you're learning right now is just that first step, because from here on out are things you guys already know how to do. Clearing fractions is the main issue today. So if you have any questions, it should be at this point, not moving forward. Moving forward, we're just solving. And if you have issues here, we need a lot more basic skills help. So we divide both by 40, reduce if you can, we cannot, so that would be my final answer. Okay, moving on to number 3. Okay, so common denominator here is 2, 4, and 7, so the least common one would be 28. I'll show you real quick like a different way. Instead of writing 28 next to each of those, you can also just write 28 like this, or maybe put it on both sides if you want to. And you could go through each term. So I also write it like this, just trying to show you all the options. So I go 2 goes into 28 14 times, and then I do 14 times negative 7 is negative 98. Okay, and then I just restart with the next one. So 4 goes into 28 7 times, then 7 times 3, u, don't forget the u, is 21. So if you want to like write it like this, it's exactly the same thing we did above, just showing you different ways. So, and then 7 goes into, this is a closer 28, 4 times, so you get negative 20. And again, I have cleared the fractions, and from here on out is an Algebra 1 problem. So negative 78 equals 21u, divide both sides by 21, and then we decide, can we reduce our fractions? Here we can. They're both divisible by 3. If you don't know the 3 trick, the 3 divisible by 3 trick is if you add the numbers together and if that's divisible by 3. So for example, is 78 divisible by 3? Well, 7 plus 8 is 15, and 15 is divisible by 3, so 78 is divisible by 3. Just in case if you don't know that. Same thing with 21. I think we know off the top of our head, of course, 21 is divisible by 3, but 2 plus 1 is 3, so that's why it's divisible by 3. Little fun fact for the day. So negative 26 over 7 would be your final answer. Okay, we're trying a lot of these because, like I said, as easy as you guys think it is usually during the notes, you make a lot of errors for the rest of this school year. And you guys try to get in the habit of like making common denominators, making all this big fraction mess. Clearing fractions will be your favorite thing to do if you start understanding why we are doing this. So always get in the habit to clear fractions. But here's where you guys start going wrong when you're going to do problems in the future. If you just have, for example, like the right side of this equation is 1/5 x, like minus 1/2. Let's pretend there's another x there. You can't clear fractions if it's just an expression. Okay, so here we would make common denominators, we'd keep our fractions, and we'd move on. You can only do this clearing fraction stuff, just to clarify this, if there's an equal sign and we're solving for x. But if you're just adding fractions together, 1/2 plus 1/3, that's just your problem. You have to make common denominators and all that stuff that we've been used to in Algebra 1. The reason we're clearing them is because there's an equal sign. So really start understanding the reason why and how and when I can clear fractions. So 3 goes into 30 10 times 2 is 20. 5 goes into 30 6 times. So we get, negative 6 here. 2 goes into 15. Sorry, 2 goes into 30 15 times, negative 15. So we add 15 to both sides. You get 35 equals negative 6x. So x equals negative 35 over 6. Okay, one more. before it lets you guys do one by yourself, and then we should be very warmed up for the rest. Okay, so our denominators here are 2, 7, and 5. Our least common denominator would be 70. Okay, so sometimes, like you always like list, the quickest way I like to see like what's my least common denominator is I take the biggest one and I usually list out their multiples. So 7, 14, 21, and I would keep on going until 2 and 5 can both go into those numbers. Or sometimes I just multiply like the two highest ones, 35. Well, 2 doesn't go into 35, so sometimes I have to multiply all of these numbers together to get the LCD, which is what happened here. So the one that there are all can go into is 70. And let's say, for example, you pick like a higher number than 70 that they all can go into, like 140. Like for example, 140, all three numbers go into, but that's not the least common denominator. That's fine. You can still do 140 and multiply everything by 140. You just got to reduce a lot at the end of your problem. But so just in case you go higher in your least common denominator, that's totally fine. You're going to get the right answer if you know how to simplify. So don't worry about that. So 2 goes into 70, 35. Multiply that by -3 to get -105. 7 goes into 70 10 times to get -40. And then 5 goes into 70. Sometimes, is it 7? 5 goes into 70, 16? Let me do this with my calculator. 14. Okay, -28. Okay, and then we just solve, so I get -105x. If I bring 40 over, I get 12 left over. So x equals -12 over 105. I'm going to use my 3 trick again. So both 12 and 105 are divisible by 3. So you get -4 over 35. So pause here, try number 6 all by yourself, and then return back for your answer. All right, number 6, you should get 1 over 18 as your final answer, and I use a common or a least common denominator of 12 to clear my fractions. All right, so we know how to solve equations back in Algebra 1. So what we're going to learn here is that there are different types of solutions in this class. So we're used to this. We're used to having one solution, like solve an equation like this, and you get x equals some number, right? We've been used to that for several years now. Now we're going to introduce 2 other options to you. There's a such thing as getting 0 solutions. And how would you ever say there are no solutions to this problem? That's if you get a false statement, such as 0 equals 2, 3 equals 4, something that doesn't make sense. And if you notice, there's no variable here because the variable has disappeared. So that's why you get a false statement. So like the x's cancel out and you get some weird equation that doesn't make sense. That means no number in the world will make that statement true, which is different than what if I have infinite solutions, meaning any number in the world you pick will make that statement true. That means you get a true statement, such as 3 equals 3. You usually get a 0 equals 0, something like that. Okay, so again, now we have either one solution like we're used to in Algebra 1. You can have a 0 solution option or an infinite solution option. Infinite solutions are also known as all real numbers as well. So both are interchangeable wording, so make sure you guys know that. Okay, so we're just going to solve this like how we normally would and see what happens. So we're going to distribute the left-hand side. -6w minus 6. Distribute. So 2 minus 6w minus 7. Combine like terms on the right-hand side. If I notice, I have minus 6w on both sides, so those cancel. And I'm left with -6 equals -5. -6 equals -5 does not make sense. Okay, that's a false statement. Okay, so that means there's no answer to this problem. That means there are 0 solutions. That's what your answer would be. Your answer is not -6 equals -5. That's not the answer. The answer is there are no solutions. Nothing you plug into W would make this statement true. Number 2. So we solve this one. So distribute. And solving these should not be the hard part. Solving this is the easy part. We're just trying to see what else can happen when we solve equations. Okay, let's combine like terms on either side. Okay, so I'm going to bring the 24 over, and I'm going to bring the 2u over. Again, if you need to take more steps than I do, please go for it, but I'm not going to go over solving equations since that's a prerequisite to this class. So divide both sides by 10, I get u equals 3. So we're just back to a normal equation. U equals 3, there's one solution. That's fine. Okay, so this is like a normal, what we're used to problem. Again, this means that the only number in the world that will make this statement true is if you plug in 3. Okay, if you plug in 2, if you plug in something else, it won't make the statement true. That's what solving an equation means. Okay, number 3. So let's distribute this. So you get -3v minus 3 plus 7v equals 4v plus 4 minus 5. Let's combine like terms on either side. So I'm going to get 4v minus 3. I'm going to get 4v minus 1. Whoops, do you see that? The 4v's are going to cancel out. So I'm going to get -3 equals -1. That is not a true statement. It doesn't even make sense. So you say there are 0 solutions to this problem. So try number 4 all by yourself and then return back for your answer. All right, number 4, this is the one of infinite solutions. Okay, so as you saw here, the variables canceled out and you got a true statement such as -4 equals -4. And then you would say either infinite solution, so any number. If you plug in any number in the world, you plug that into y at the beginning, that would make this statement true. So anything works. So you say infinite solutions are all real numbers, same idea. The place where most people make a careless error is with this type. So typically, so we got -4 equals -4. A lot of the problems you're going to see, like for example, if you continued on with -4 equals -4, a lot of people probably got to 0 equals 0 maybe. And people think 0 equals 0 equates to 0 solutions. That's what you guys just like assume because of like the 0 thing. You're like, oh, 0 equals 0 means 0 solutions. That's not true. So don't be that person who makes this careless error. 0 equals 0 is a true statement, so that means it's infinite solutions. Okay, so don't get like, I know the semantics of it is 0 and 0 and you're trying to get into that. Please do not fall for that trick. All right, so now we're going to get into, yes, word problems. We're going to have to read and then write things for our math teacher. You guys are lucky we took out a lot of the word problems this year, so make sure you guys are being very thankful for the ones that we're even giving you. All right, so what we're going to do is just write an expression for all these. Again, equation will be an equal sign. Expression is non-equal sign. So it says, let n be the middle number of 3 consecutive even integers. What does that even mean? So we're going to say n is equal to the middle number, because that's what it told us to do. Okay, of 3 consecutive even integers. Let's break that down. That sounds confusing. Okay, so we have 3 numbers. They're even, consecutive meaning like in order. So you have like 2, 4, 6. For example, that's 3 consecutive even integers. So how am I going to write the other expressions for, so for example, n right now is equal to the number 4. How would I write 2 and how would I write 6 knowing that n is equal to 4? Well, since they're even integers, we know even integers are 2 away from each other. So if I wanted to write the smallest number, I would just subtract 2 from n, right? Because it's 2 away. If I wanted to write the biggest number, again, it's 2 away, but it's 2 more than the middle number. So like on the side, I always like to designate the expressions for whatever we're talking about. And then what is the question asking? It says, write an expression for the sum of these integers. So all we're doing is adding these integers together. So n minus 2 plus n plus n plus 2. Combine like terms. The 2's cancel out, so you just get 3n as your final answer. Okay, again, trying to point out always where you guys make mistakes. An expression is just this, okay? It's like numbers with variables. If I said write an equation, which we do not have enough information for, equation has an equal sign. So expression doesn't have an equal sign, equation has an equal sign. So make sure you guys are understanding, again, the vocabulary, especially in this class. You probably didn't have to pay attention in earlier classes. This class, you need to pay attention to what I'm asking so you do not give me something I don't want. So Matt has a bookcase with Y shelves. There are 11 books on each shelf. Using Y, write an expression for the total number of books. Okay, so you have Y shelves, and there's 11 books on each shelf, so 11Y would be your answer. Okay, because again, we're just writing an expression. Okay, it says last week Ivan drove 272 miles. This week he drove K miles. Okay, he could have driven 10, he could have driven 1,000,000, we don't know. We're call it K. So using K, write an expression for the total number of miles he drove in 2 weeks. So last week he did 272. This week he did K. So we just add them together, and that would be our final answer. Obviously, this is warming us up until when we have to actually solve equations, but writing expressions and translating sentences into math is what we were going to practice in this section. All right, last section for today. We're going to solve for a variable. Okay, so we're going to pick a specific variable. So you're going to get equations that have multiple variables, and I'm going to say solve for this particular one. Okay, it's very easy to get confused if you don't have good basic solving equation skills, but for most of you guys, this should be pretty easy. So I'm mainly doing this for obviously this section and everything, but this is really important. Your science teachers have asked us to go over this several times because when you guys go into chemistry and that kind of stuff, I think, or physics, you guys tend to not to be good at this skill, so we're trying to incorporate it into this class as well, so your science teachers will love you. That's the whole point. So we're trying to help you guys impress your science teachers by showing you guys how to do this. All right, so you're going to be given an equation, for example, number 1. You have x and y in the equation, but I particularly say here solve for x. When I say solve for, that means isolate. So we're trying to get x all by itself. So how do I do that? Well, obviously you need to bring 6y over to the other side. Okay, so we're going to bring 6y over, and I want to get, again, x isolated, so I divide everything by 18. And then we would simplify, as always, so x equals y over 3, and then this simplifies to 1 over 6. Again, just to clarify, because some of you guys still don't understand this, y over 3 is the same thing as 1/3 y. That's the exact same thing. Because sometimes you guys are like, well, Alex said it this way. It's the same thing. Okay, these mean the same thing. So y over 3 and 1/3 y are the exact same numbers. Okay, and obviously I could have easily switched this problem up if I said solve for y instead. We would have a totally different equation. So make sure you guys are looking at carefully what exactly I'm asking for. This one says solve for y. So we're going to get this by itself. How do I get the y by itself? Well, first that 8 is in the way. So don't falsely do this. I mean, you're going to get the same answer eventually. A lot of you guys are going to want to distribute first. It's going to take you a lot longer. You can simply just divide by 8 first to clear that. Then I'm left with c over 8 equals y plus k. If I want to get y by itself, I just have to subtract k from both sides. So yes, these aren't that pretty of answers, but that's what happens in this class. You're not going to get nice whole numbers very rarely. Number 3, solve for b. Again, do not distribute. It will just make your life a little bit harder. We can just easily simplify this quicker by dividing both sides by 10. So now I'm left with b plus 1 equals r over 10. To get b by itself, we're going to subtract 1 from both sides. Number 4, now we're into fractions. And now we learned earlier how to clear fractions. It's all coming together. So we're solving for a. We're getting this part by itself. Okay, this divided by 6 is in the way. Oh my gosh, I can clear fractions now by multiplying both sides by 6 by the LCD. Okay, so I multiply both sides by 6. So the 6's cancel out. And I'm left with 6L equals a minus b. Add b to both sides, and there's your equation. Okay, last one before I let you do one by yourself. This one says solve for y, so we want to get y by itself here. Okay, so this is the exact same thing we just did on the previous problem. In the previous problem, it said divide by 9 like this. This means the exact same thing, 1/9 times all this means the same thing. So to clear fractions, we multiply both sides by 9. That way this clears out. So I'm left with 9w equals x plus y minus z. You could bring the x over, and then you could bring the z over. I'm just going to do it in one swoop. If you want to take your time, please do. So I'm going to bring the x over by subtracting, bring the z over by adding. And that is it. And again, we're adding and subtracting, so those are commutative properties, so those could be a little bit out of order, but it's making sure your signs are the same. So pause here and try number 6 by yourself, and then we're done with the first half of 1.3. All right, for number 6, you should get -4/5 equals u if I wanted to solve for u. So a little quick lesson in algebra. Remember, if we're dividing by a number, it's the same thing as multiplying by the reciprocal. So a little bit of algebra quiz there. All right, and that is the end of section 1.3, the first half.